Hello everyone. So now we are going to do one more lab. In this one, we are going to create another topology. In that topology, we have some assignment. We need to do that steps. Okay, but we will do this step by using the extended name. We are going to do the extended name access list. Why we are going to use the extended name? Because if we want to add any service later, it is easy and we can do in the extended name one. If we do in the standard, we cannot do also in the extended number one. We cannot insert the any new condition, any new access list. If you want to add some more what we can say policies in between, then we cannot in the extended number ACL. If we want to do that one, we can do in the extended name one. So that is what is the syntax for that one. We need to write IP access list extended, and here in the name we can give any name. After that we can write permit or deny whatever we want to do. Then the protocol, then source address and the source wildcard mask, destination address and destination wildcard mask. If we are using single IP, then we will write host and the IP address of that one. If we want to use the complete subnet, then we will use the source wildcard and source address. Example, if I want to block complete subnet like 192.168.1.0, so here in that scenario we will use 1.0 network ID here and the wildcard mask here. And destination, if you are having single IP, directly we will write the network ID of the destination. If you want to block particular single IP, host and give that IP. If you want to block complete subnet, we need to block, then what we will do, we will write the network ID and the wildcard mask of that one. After that, operator, example equal to, less than, greater than, whatever operator we have. Example, if you want to block the port 80, then we will write equal to and here port 80. And at last we need to write permit IP any, and this one we need to apply under the interface. So go under that interface and write IP access group and give the ACL number, whatever number we use, and if it is out or in, we need to check how traffic is flowing and we need to apply there. And if you see here, we have some instruction here. We need to do the lab as per this instruction. So what I will do, first of all, let me create the new lab. So we will follow the instruction because the new lab topology is different. So I will follow that new lab topology. In that one, what we have two switches. Okay, so I will take one switch here, two switch, and we have the two router in this topology. This is a basic setup, but here we will learn some more ACL, so we can become little expert in that one. And here we can take some more computer. I will take one computer here, one computer here. This is the basic topology. We have this topology in our assignment, and they give some instruction we need to follow to fulfill that one. And here in this router we don't have interface. So what I will do here, I will switch off this one and I will break the interface from here. I will insert here. I will power on the router, and then I will take the cable. I will connect from here to here, this one. Okay, and here we can give the name, whatever name you want to give. Example, I can give here R1 and here will be R2. So this is a topology IP schema. We can use anything, whatever we want. Here I can connect one computer here this way. Okay, so this is our topology. We need to do the lab in this topology like this. So what I will do here, I will write here this one. Let me give the IP schema. I will give 192.168.1.2, and we will apply this here to this computer. So let me go here and apply here. This and the gateway we will use 1.1. So we will give the 1.1 here, and 1.1 we are going to configure here this side 1.1, and this will be the gateway to our computer, as we already know that one. So let me give here, this is 3, and now let me copy and paste this here, and here let me put 1.1 is a gateway. So basic stuff I done here, and this switch name we can give anything. This one I can write here switch 1. Okay, and what else we can say here, this is R1 R2, this is a switch 2, we can give switch 2, and here this IP we are going to use here, and this side we are going to use 192.168.1.2 2.1. okay, 2.1 this side, 2.1. so let me keep this here, and here this machine we will assign the 2.2. let me assign that IP here, and here will be 2.1. okay, and this router, what we will do here, we can give the IP schema 192.168.3.2. okay, whatever we need here we will assign this IP to this interface. We can use any IP schema. I am using this one. okay, so now here 3.1, here 3.2. if you are confused, let me paste again this IP to this interface and this IP to this interface, like this. And what else we have? Everything is good. Now we can start the configuration. So let me take the notepad here. In this notepad, first they told, what they told, configure the ACL configuration lab, configure the telnet on R2. so this is the R2, we need to configure the telnet here. And what they are saying, check all the PC can telnet to R2. so all guys, these computers can access the telnet. We need to do that one. And we need to check R2 and R1, R2 can ping. so all this guy can ping R1 and R2. so we will do that also. After that, what they are saying, configure and apply the name extended ACL on R1 as follow. so we need to do here, what we need to do, we need to write permit telnet PC1 to R2. so we need to permit PC1. so this is a PC1, he can telnet the R2, and telnet to R2 must be denied for all the network, means all the PC in the network. so only this guy can telnet, remaining all guys should not telnet the R2. this is first condition. Second condition, permit ping PC2 to R2. so PC2 can ping to R2. okay, this PC, that is PC2 can ping to R2. and other thing, what he's saying, ping to R2 must be denied for all the computers. so only PC2, let me repeat again what I am saying, what is our requirement. This guy can telnet here, all other guy cannot telnet. okay, and then again he's saying this guy can ping this one, but all other guy cannot ping that one. so this one we need to implement by using the extended ACL name one. we need to use the extended name one to do this one. so let's do the configuration. First of all, we need to assign the IP address, and we need to configure the telnet, and we need to enable some routing protocol so they can exchange this route. okay, this route will go to this router. okay, this route. so we need to enable any routing protocol also. so let me do the configuration. First we will do, this is very simple only. First we need to assign the IP address, and then we need to configure the telnet. all the stuff we need to do. so what I will do here, I will write here R1 configuration. R1 configuration, we will do enable config t, then host name R1. I wrote R1 host name. Then we need to assign the IP. I will write interface fast Ethernet 0/0. This is fast Ethernet 0/0. I will write IP address. I will give 192.168.1.1. Give space 255.255.255.0, and I will write here no shut. And then I have one more interface fast Ethernet 0/1. I will write IP address 192.168.3.2, then 255.255.255.0, and then no shut. This one I done. Now I need to do this one also. so I will write here interface fast Ethernet 1/0, IP address 192.168.2.1, then 255.255.255.0, and I will write no shut this one. okay, so this way I assign the IP to this 3 interface router, this 3 interface. And now we can, if you want to create local user, you can create. No need, actually they did not told, they told only R2, right? We need to telnet R2 only. so in R2 only we need to create local user and also configure telnet, but we need to enable the OSPF here. so this route will go to this R2. so what I will do, router OSPF1, okay, under that interface fast Ethernet 0/0, IP OSPF1 area 0. Then again interface, what is the interface, fast Ethernet 0/1, IP OSPF1 area 0. Then after that again interface fast Ethernet 1/0, IP OSPF 1 area 0. Okay, these three command I wrote just to enable the OSPF. Now let's do the configuration for R2. So R2 configuration is very simple. Let me configure from copy this whole thing and we will paste and we will modify as per our requirement. So I will copy, I will go here, I will write here, and now let me modify. This is Z2 and here also I will put 2. So I am here inside this. I have only one interface, so no need for this 2. I will remove this 2. Here fast Ethernet 0 by 0, this should be 3.2. Okay, so this is a 3.2. And here what we need to do, enable the OSPF under this only one interface. So this one we finish. Here let me write this one. Okay, and also here what they told, we need to configure the telnet. So what we will do, let me write here telnet configuration. First of all, I will give the enable secret. We can give any password, and then I will create one user. This is a username admin. Password we can give anything, admin. And now I will do the telnet configuration. We will say LAN VTY 024 login local. This way we give. Okay, so this is a telnet configuration, and here just I am assigning the user. This is a secret password and this is one user I assign, and then I enable the OSPF. This is only the basic configuration. Okay, just to make the connectivity. So let me copy paste this configuration in the R1, okay, and R2, and we will test. So let me go here, I will paste here, I will write here no, and then let me paste here. Everything is good, no error, nothing, everything is working perfectly. So now I will copy the R2 configuration from here to here, and I will paste that also in the R2 here. I will write here no, and then I will paste here this one. Here also everything is good, no error, nothing, everything is good. Okay, so now what we can see here, something wrong here. I wrote something wrong. Let's see. Here he is saying duplicate IP. So let me check what I done. Okay, in the R1 I done something mistake in the R1, so this should be 3.1 in the R1. If you see here, let me show you the R1. This is R1. F0 by 1 should be 3.1 here. This should be 3.1. So let me correct here. I will go, I will write here interface. What is the interface? F0/1 IP address 192.168.3.1 255.255.255.0. okay, and no shut. Let me check here, show IP interface brief. So now here if you see, we don't have any duplicate here. Let me save the configuration and let me go here and check here also, and let me check now, show IP interface brief. Here also good, no issue now. And let me check, show IP root OSPF. We are getting any root with the OSPF or not? Still not, maybe it will take some time. OSPF, yeah, now urgency came, so neighbor, they form the neighbor now. So let's see, show IP root, show IP root, show IP root. They are in the extract, so it will take some time, then they will. We need to have the root. Let me check here, still they have or no. We can do fast forward if we don't want to wait. Now let's see, do we have any root? Show IP root. Still no roots, because we should have this network 192.168.1.1. We configure OSPF here, right? I paste here fast Ethernet 0 by 0. We enable here, or I can write here, show IP OSPF interface brief. So this interface we have the OSPF fast Ethernet 0 by 0, 1 by 0, F0 by 1. So this is good. Here let me check, we have interface show IP OSPF interface brief. Here also we enable the OSPF, so it should work. Show IP route, still we don't have. Why we don't have? Let's see here. Show IP route, show IP OSPF neighbor. They struck in the Xstart. Generally when MTU mismatch, they struck in the Xstart, so we need to check what is the issue. Let me clear IP OSPF process. Maybe they taken the router ID wrong, that's why it is struck. Let me start. So now I can clear here also, clear IP OSPF process, because they are taking the router ID. I think they taken router ID here as a 3.1 and here also 3.1, that's why they struck. Now I do the neighborship reset, so it should come now. We will see. Show IP route, still no. I can write show IP protocol. If you see here, router ID is 3.2 here, and let me check here what is the router ID. Show IP protocol. Here also same router ID. If you have same router ID, then they will not come up. Why this guy taken this router ID? Because we assign here before 3.2, so they taken that router ID. So we need to clear here, and it is taking time to clear. So manually we can configure the router ID also. I can write router OSPF1 router ID. I can give 192.168.1. What is that? 3.1. I can give 3.1. Okay. Now let's see it change or not. Show IP protocol. It is changed now. Router ID change. They form the neighborship. Okay, so now it should work. Let me go here and do here. Here I can write show IP route, show IP route OSPF, show IP route OSPF. Why it is still not coming? Show IP route OSPF. Now it came. Okay, so we have the route, that is 1.0, 2.0 network is coming here. Let me save here. What error we are having, what issue we have just now. When we studied the OSPF, we told that router ID should be unique. By mistake we configure this IP here also, and same IP we configure here also. So what they will do, first they will check the loopback interface. If we have any logical interface, they will take that one as a router ID, but here we don't have logical interface. If we don't have logical interface, then they will look the physical interface, which one is having the highest IP. So this is the highest IP, so this guy taken this one as a router ID, and here also by mistake we assign, so here also they taken this one as a router ID. I change the ID, I clear the process, but still it is, this guy is having that IP only as a router ID. So what I done, I manually I configure here this one. After that they start working. Okay, so now we can check our lab. What is our requirement? They told us configure telnet in R2. We done that one. Check all PC can telnet the R2. So we need to check this PC can telnet the R2. So R2 IP is this one, 192.168.3.2. So we need to write here telnet 192.168.3.2. okay, so telnet is working here. Okay, telnet is working. So I will exit. PC1 is telnet is working, and he told ping should work. So ping should work only, then only we can do the telnet. But anyhow, as they are asking, we need to ping also. So ping also working for R1 and R2 and R1. This is a R1 R2. So ping is working and telnet is working for this PC. Which PC? This is a PC1. Now let's go for PC2. I will do here also. First I will ping. Okay, I will ping 192.168.3.1. This R1 is pingable from this PC, and also 3.2 is a R2 is also pingable for this PC. So what else we need to do? We need to check the telnet. R3 we can telnet or not. So I will write here 192.168.3.2. Telnet is also working for this computer. Okay, enable, and then CISCO is a password. So now I can do the telnet. Okay, telnet is working. So this second PC is also good, no issue. I need to go to third PC. So I will go here to third PC. Here I need to do the telnet and ping. So let me do ping 192.168.3.1. Ping is working for R1, and now I will do for the ping for the R2. After that they told we need to do the telnet, so I will do the telnet also. So telnet 192.168.3.2 3.2. okay, 3.2. I will write admin and then enable secret password we give Cisco. So it is working, no issue. So PC3 is also good, everything is working for PC3 also. So we check this one. What we check? This one, right? This condition we check. All PC can telnet R2 and ping R1 and R2. So this one we done. Now what we have the new task. If you see what they told us here, permit telnet from the PC1 to R2. So this PC1 can telnet the R2. Remaining computer should not telnet that one. So we need to do this one. So how we can do? First of all, we are doing the standard, that is extended name ACL extended. So we need to apply near to the source. So this is our source, this one. So we need to do here. So in the R1 we need to configure. So what we will do here in the access list, I will use the extended name they are saying. So how we will configure? We will write IP access list, IP access list, and we will write extended and give any name. After that we need to write permit or deny. So I will write here permit. What they are saying? Permit TCP. This computer they are asking to allow, right? So I will write permit TCP 192.168.1.2, and what other computer here, that is router. Router also we can say the host. So this one is a host. So this is a 3.2. So I will write here 3.2 192.168.3.2 and equal to, what is the equal to? Telnet. So telnet is working on which port? Port number 23 or 22. We can write that port number here. If you want, you can write telnet also. If you want, you can write the port number also. So with this command they will allow this PC to telnet the R1, this IP. Okay, this IP can telnet this IP with this command. After that they are saying we need to deny. Remaining we need to deny. So what we will say? Deny, and I will write here which protocol? TCP. Why I am using TCP? Because telnet is working on the TCP. So I need to deny complete subnet. So I will write 192.168.1.0. I am blocking complete subnet. I am blocking this one also, and in future any more computer come 1.4, 1.5, 1.6, anything, I will block complete subnet. That's why I am writing here. I am not going to write the host. When we write host, if you want to assign only one IP, then we will write host. If you want to block complete subnet, then we will write deny TCP and the network ID of that one, then the wildcard mask. So what is a wildcard mask of class C? 0.0.0, that 255. And what I need to block? I need to block same that one, that router. So that is single router. So I will write host and give that router IP. Okay, 3.2. And what I need to block? Same thing, telnet I need to block. So I will write here telnet. And also I need to block this network also, 2.0. So I will copy this same command. I will write here this one like this, and here I will change this as a 2. Okay, and this remains same. So this network also unable to telnet that one. So 3 deny statement I wrote. After that what they are saying? We need to permit. What we need to permit? Permit, they are saying ICMP, right? Permit ICMP, because ping is working on ICMP. So permit ICMP for computer, which? This computer. They give the computer, which computer they told? PC2. This one PC2. PC2 is this one. So what I will do here? Permit, give the IP of that PC2 192.168.1.3, right? 1.3, this one, this computer 192.168.1.3. permit this one, and then the other IP, this is also single IP, so I will write host, and I will write here 192.168.3.2 and equal to what I will write here? Echo we use for ping, and echo reply also. Reply should also come, so I can write one more. I will say echo reply. echo and echo reply, we can say that one. Okay, so here if I want to do, I can write this way also, echo reply. Echo is also enough, but anyhow echo reply, like this. So this one I wrote to allow this computer to ping this one. After that I need to deny all subnets. So same thing, I will copy these two command here like this. I will write here deny this one, but not TCP. This should be ICMP. This one also ICMP, and here what we will write here, what we are denying echo. So I will write here this one equal to echo. Here also I will write EC echo. After that we need to apply. So where we need to apply? We need to apply to the interface. If you want to apply here, you can apply here, you can apply here, you can apply here. Now look the traffic flow. Traffic is coming. How traffic is coming? Traffic coming this way, this way. If you apply here, then again you need to apply here. This is a common for this traffic, so better to apply here. Because the traffic will go this way. So this is separate, but they will meet in one place, so better apply in this place. So what I will do, I will write here interface fast Ethernet 0/1, and then I will write IP access group, and whatever the name we give ABC, and then out, because it is going out. This is a ABC and out I wrote. That's all. This way we can apply. So let me copy and paste. Let's see it will work or any issue we will get. I will go in the R1. I will paste in the R1 this. Let me go to the global configuration mode. I will paste this here. Something wrong, maybe we done spelling mistake here. Okay, let's correct what we done here. Permit ICMP host, this one host equal, and no need to write equal. When we are writing echo, just we will write echo instead of equal, we will give echo. So that is the issue here. Okay, so what I can do here, I can remove here the equal. This equal should not there, like this, and here also like this, and here also I can remove this one this way direct. So I can copy and I can paste again. We will have some issue, we will see, and we will fix that one, because some commands go up and down. If you want, we can check also show IP access list. If you see here, first we are saying permit this computer, okay, to access the telnet. Second we are saying deny this network. So this one is okay, and after that we are saying permit this to permit. Okay, yeah, this one we are saying permit this one and then deny this one. So good, no issue. It will work perfectly. If something go wrong, then again we need to go inside and we need to add. Example, if something mismatch here as we done before, what we need to do, we need to go in the IP access list ABC and give the number maybe 15, and then if you want to permit deny, we can do this way. But here already we have in the sequence, we are saying permit this computer to telnet this one and deny this network and this network deny. So it is denying. Then again we are saying permit the ping. So these two command used to permit this 1.3. So this is okay, and we are saying deny this one. So this is good, no issue. Okay, so now let's see. This computer can what we can say telnet. Okay, so let me go to the command prompt, not this one. I go to the command prompt here. Before he can telnet, now also he will do telnet. Let me go telnet 3.2. Telnet will work for this computer, but he cannot ping. Okay, I will show you, he cannot ping. Now let me exit and ping 192.168.2.3.2, right? 3.2. See, he can telnet but he cannot ping. He can telnet but he cannot ping. PC1, this is the PC1. If you have confusion, let me write here. This is a PC1, and this is a PC2, and this is a PC3. Okay, what we done here, this PC can telnet here. If you see, telnet is working here. Telnet is open. It is working. This PC is working telnet. but he cannot ping. As per our requirement, this is good. If you see what they mention here, here PC1 can telnet here. Okay, so this one is okay, good, and he cannot ping. So now let's go to this machine and check here. This machine should not telnet as per the requirement. So let's see here, telnet should not work for this computer, so it is not working. Let's see, but he should ping. So we will see here now. I see remote host not responding, so he cannot telnet, but he can ping. So let me see, he can ping or not. He can ping. If you see this condition, PC2 permit ping, but he cannot, other guys cannot ping. So other guy is not pinging always. We just now we check, this guy is not pinging, and let's see, this guy can ping. He will also unable to ping and unable to do the telnet. Let's see, telnet he can do, he cannot do the telnet. He cannot do the telnet. And if you want to ping this guy, he cannot ping also, because as per our requirement only this PC1 PC2 is having some access, PC3 is not having any access. Imagine later one more engineer join in your organization and he connected here and his IP is 192.168.1.4. okay, this is his IP, and here is the IP I will assign, and the gateway will be 1.1. Now he can do anything? No, he cannot, because if you see here, you can write ping 192.168.3.2. he should not ping as per the requirement. Only these two PCs having the access, but he cannot. If you see here, destination host unreachable, and also he should not able to do the telnet also. Let me show you telnet 192.168.3.2, because in the condition they told only this guy can telnet, remaining all computers should not telnet. That's why we block complete subnet. If we block complete subnet, then it will not work. Okay, imagine maybe your manager is saying that allow this guy to access the telnet. So now you need to do the telnet, allow the telnet to this guy. How we can do? So we can check here in the router. You can check in the router, first of all the list here. Here if you see this first one, you are saying the permit this one. Okay, you are saying permit here. This is for telnet, first one, and here you are blocking. So what you can do, as per your manager request, allow this guy to telnet. So you can insert, maybe you can bring here above here or here. If you insert the new rule, this is a sequence number, this 10 is a sequence number, 20 is a sequence number. From 20 they are going to block. So if you write 11, 12, 13 or 15 or something, or above or below, above 10 or below 10, before 20, if you apply new policy here, new rule here, saying that permit TCP host 1.4 this one, 1.4 to this one and this one, then it will start working. Let me show you how we can do. Simple. In the extended name ACL we can do that one. Okay, so IP access list and extended, and what is the name? ABC. After that you need to write number here. If you press question mark, you can write the number from 1 to this one. So if you want to bring above this one, we can write 1 here. So that rule will come above this what we can say sequence number. Or if you want to bring between this 10 and 20, you can write here 15 or maybe 11 or anything. Let me give here 15. Okay, I give 15. After that what I am giving permit. What I need to permit? TCP. Which protocol? Telnet is working in the TCP, so I will write TCP. After that I need to allow only one computer, this one, so I wrote host. I need to give the IP of that one. IP is 1.4, and then other one, what is the router IP? That is also one IP, so I will write host. Then what is the IP? 192.168.3.2, right? 3.2. And what I need to allow? Equal what we need to give? Telnet. Okay, telnet, and press this one. Okay, and if you want to check, do show IP access list, and if you see here we have new entry here. If you see, we have the new entry here. If you create without using the sequence number 15, it will come here. so they will block here directly, but you need to put in this sequence, you need to bring somewhere here. Before 20 you need to bring, so I bring here, I write 15, so it came here. If I write 1 2, it will come about the 10. Now this guy can telnet. If you see, now this guy can telnet. Before he is unable to do the telnet, now telnet is working. Now telnet is working. If you see, it is working. He can access now. Everything is okay. Enable, and the password, secret password is Cisco. Okay, but if you check ping, he cannot ping. Okay, he cannot ping. Imagine your manager told allow him ping also. Then how you will do? Check here again, go to the router and check here. You want to allow the ping, so how you can allow? Where we are denying? We are denying where ping? We are denying ping here. Okay, you are denying here, somewhere here. So you need to insert the new policy here, somewhere here after 50, or you can do here also, top, anywhere you can do. So maybe I will insert one rule here before 60, because in 60 I am denying. Okay, this sequence list here I am saying that deny. So if I create a new policy, new rule above this one, that will work. So what I will do here, I am already in that one. Okay, I am already in the IP access group extended ABC. I am inside that one only already. Now if you press question mark, you can write here sequence number. Okay, I am already. If you want to make any changes in the rules, you need to write IP access list extended and give the name of the access list. So I already wrote that one, so I am inside that one. If you see this one, I am inside that one. So now I need to give the number. So where I need to allow that one, this is blocking, so above this one, so I will write 55. Okay, so I will write here 55. Then what I need to do, I need to permit. So I will say permit. What I need to do, I need to do ICMP. Okay, ICMP. Then I will write here host. Which host? 192.168.1.4, new host, this one. After that, what I need to, another host, that is our router IP is 3.2. Okay, and equal what I need to do, if you press question mark, echo, I need to allow echo, right? This one. So I will write here echo, EC, I wrote echo. Now let's see this guy can access or not. Ping, before ping is not working. Now let's see ping is working. And if you want to check here, you can check also. How you will check? Do show IP access. If you see, I insert the new rule here, and this one is a 4 match. So we have the 4 packets match this policy, means they use this policy 4 times, this one 46 times, this one 96 times. They match this one. They hit this policy 12 times. They hit this policy 4 times. They hit this policy 4 times, 18 times, 4 times. So if your manager give you any new task later, maybe they will say they have another new computer, new engineer, or maybe they will say, okay, allow this guy ping also. Your manager will say that this guy can telnet, but he cannot ping, right? Allow them ping also. So how you will do? You need to check here. Where is the sequence? Our sequence for this PC 1.2. Here we are allowing the telnet, and where I am blocking, here I am blocking the ping. I am blocking here ping, right? Where is the ping I am blocking? Here I am blocking the ping. Where I block the ping? This one. I am blocking the ping here. So I can go here in the 56. Above 60 I can allow. Above 60 I can allow that one, because here I am blocking the complete subnet ping. So let's do here. I will write here above 60, right? So I can say 56. 56. I will write permit ICMP. Which host? Host. I will give 192.168.1.2, this machine. Okay, and give host. And what is our router IP? 192.168.3.2. Okay, and what you need to allow? You need to allow ping. Ping, if you want to allow, what we will write? Echo. Okay, like this. And now let's check. Before, this guy cannot ping, only he can do the telnet. If you see here, destination host unreachable. Now it is working perfectly. Okay, and you can check here where we do that one. Do show IP access list, and check here what we created, the new policy. If you see, this is a new rule I added here, this one 56. Permit ICMP for this host to go to this host, what? Echo, and it is match 4. So they hit this policy 4 times. 4 packets hit this policy. So this way we can configure, we can modify. If you have any new requirement, you will check, you will do. Because in the real scenario you will have lot of ACL. Maybe you have 200, maybe you have 300 ACL. You cannot delete all and retype again. So only you will insert, because you have the number here 10 and 15. So in between you can insert more 4 policy here, or 5 policy here 10 policy. Like this we can do. Okay. So with this one we have the idea about the ACL. So let me stop.